Hello learners and everyone, wherever you are. Welcome to Black Slides Online Lessons, the only home of high quality lessons online. We have great news for you who were looking for online lessons, that now we are offering a full Msce curriculum in which you have the privilege of learning biology, chemistry, agriculture, English language, geography, additional mathematics, and business studies. Once again, my name is Mr. Pochilola. Feel free to contact us on the numbers shown on this screen, and most importantly, don't forget to subscribe to our YouTube channel. By subscribing to our YouTube channel, you have the privilege of accessing all our free products, including subject updates, free tips on how to excel academically, and any other related news relating to our online platform. Once again, I feel obliged to welcome you to this channel. So in case you have a question relating to our pay channel or pay lessons, paid up lessons, don't hesitate to simply contact us. We'll be glad to assist you. We have a vast experience of teaching of over 25 years, and wherever we have taught, we produce high quality results, including here online. We promise you nothing but the best education experience. So welcome to today's lesson. Today's lesson is a Form 3 topic in mathematics, which is called the Msce theorems. This is a geometry topic in Form 3 mathematics. So welcome, feel free. Let me urge you to follow the video up to the end, where it's necessary to jot down notes. And actually I would recommend that you jot down notes, you take down examples, and follow on. In case you have a question, don't hesitate again to actually text me or my friends on the numbers shown here. We'll be more than happy to assist you. All right, don't forget to subscribe to the channel, as it's the only means to subscribing is the only means to get in touch with the Black Slides online content. All right, thank you very much. So once again, Msce theorems or angle properties of circles is to do with the angles, basically angles, right? It's to do with basically angles, but in a circle. All right. In Form 2, you learned about different shapes in geometry, different shapes such as the rectangle, parallelogram, rhombus, kite, square, and others. And one of the shapes that you also looked at, but not in a deeper detail, is the circle. Okay, so we're going to focus on the properties of angles inside a circle. But for us to do that, let's quickly define a circle. What is a circle? Definition: a circle is defined as a set of points equidistant from its center. A circle is a set of points which are equidistant from its center. All right. A circle is a set of points equidistant from its center. So in the definition here, we have the word equidistant. Equidistant. What do you mean? What do you think equidistant means? Well, if you thought that equidistant means having equal distances from a fixed point, then you're right. So we are saying a circle is a set of points which are at the same distance. Equi means equal distance from its center. All right, a circle is circular. When you draw it, it is rounded. It has a rounded shape like that. So if you go back to the definition, a circle is a set of points equidistant from its center. So the points are the ones that are represented by this rounded shape. So all the points along this path are the same distance from the center here. So as long as the distance is from the center to the points around are the same, then this shape is called a circle. I hope you're good on that. All right, so the distance around the outside of the circle is called the circumference. The distance around the outside of a circle is called the circumference. So the circumference is the one that is shown here in the orange. So that path is known as the circumference. So all this distance here, the complete distance around, is called the circumference. Circum, from the word circum means round. From the word this circle, we have circum, it simply means a rounded path. Okay, remember that circumference is also the same as the perimeter. So in other words, the circumference is the perimeter of a circle. And remember from your Form 2 mathematics, perimeter is just the distance around a shape. For example, you looked at the distance around a rectangle, so that's its perimeter. The distance around the square, that's its perimeter. So the perimeter of a circle is called circumference. It's called circumference. Right, I hope we are good on that. So far so good. Don't forget to subscribe to the channel so that you do not miss any lessons or videos that pop up that are posted. Right, once again, my name is Mr. Pochilola, your teacher, the anchor on this channel, but also the director of this online platform. I'm not alone. I'm with the other members. I have colleagues that will post to this channel different other subjects. Remember that we are now offering a full curriculum. We are offering a full curriculum, a full course, Msce course. That means you can learn all the subjects here. You don't have to migrate anywhere to anywhere. So just register with us and you receive all the lessons. We have a paid app channel where you can access lessons at a very competitive fee per month. Very competitive fee per month. Just get in touch with us and we'll be glad to come back to you and advise you on how you can enroll or get registered. All right, great. So the radius of a circle is just the distance from the center of the circle to the circumference. So we are saying the distance measured from here, the center, to any point on the circumference is called the radius. It's called radius, and it's singular. If you have more than one radius, then you call them radii. Radii, R-A-D-I-I. Okay, but if it's just one, it is called radius. So this distance here is known as the radius. Okay, so far so good. I hope we're together there. Then we have what is called the diameter. Diameter is simply the distance across the width of the circle through the center. All right, so if we take any point, say here, and then we strip through the circle, to the other end, passing through the center, such a line is called diameter. It's called a diameter. So diameter is full line. And what is notable about this is that alright, you can see that the diameter is just twice. It's just twice the radius. So this is radius, this is another radius. So when you add these two radii, it will form a diameter. So we are defining the diameter as the distance across the width. Okay, this is the distance across the width. Across means passing through. Yeah, so through the center of the circle, it will form the diameter. So from this slide, before we go to the next slide, we've looked at the definition. So we're saying a circle is simply a set of points, which are equidistant from the center. So if you look at the points here, we're talking about the power points passing through this path. All these points, when joined together, will form a circle. And the point which I have shaded in red is called the center. So you can see any line you draw from here to there. That's another radius. You can draw as many as possible, like that. All these radii. One is called the radius, but more than one is called the radii. So definition once again of a radius. So a radius is the distance from the center. The center is right here. So these distances are called the radii. I hope so far so good there. And let's see you have questions. If you have questions relating to this slide, please don't hesitate to talk to us by contacting us on the numbers that have been given. Okay, once again, my name is Mr. Pochilola, representing Black Slides Online Tuition. In case you have a question, don't hesitate to contact us. We are here to help you to make sure that you gain or you get the best education online. Okay, don't hesitate. It's our job. This is what we do. It's in our blood. Teaching is in our blood. Okay, we are the content experts. Okay, what we give you here is the best you can ever get online. Okay, all right, good. So what is a circle? All right, remember to define a circle. Of course, in an exam, you cannot be asked to define a circle. A definition of a circle is taken to be a trivial question, you know. But you at least just have knowledge that a circle is simply a set of points which are the same distance from the center. Okay, so all the points around, when joined, are called a circle, and that the path around the outside of a circle is called the circumference. Circum means going round. Okay, and then any line drawn from the center to the circumference is called the radius, while the line which passes through the center is called the diameter. We continue to look at more parts of a circle. Let's now look at another part of a circle, which is called arcs and sectors. So what is an arc and what is a sector? It's important for you to know the parts of a circle, because knowledge of these parts will help you to understand the rest of the discussion in this topic. All right. So an arc, definition of an arc. An arc is a part of the circumference. Okay, we have said that the whole of this path is the circumference. It's the circumference, right? It's the circumference, But if we take just a portion of it, just part of it, let's say let's select here, we select this part here, that is called an arc. So you can consider an arc as just a fraction of the circumference, or a small portion of the circumference. Okay, so this one, which is shaded in the what color is this? Orange. This orange part is called an arc. But you can also have other arcs. For example, along let's say we select this part here, this one would also form another arc, and so on. Okay, so that's another arc. We can also have another arc at another portion, like this one here. This is also another arc. Arc is just a fraction. That's another arc, a fraction of a circumference, right? Yeah, that's another arc, like that. This could be another arc there. Okay, I hope we are good on this one. So an arc is just part of the circumference. All right. Another concept we would love to look at is the fact that when an arc is bounded by two radii, it will form this part here. This part looks like what? It looks like a part of a cake. If you have ever seen a cake being cut, this portion here is going to form what is known as a sector. Rather, it's called a sector. Okay, so when an arc is bounded by two radii, so here we have two radii. Okay, you can see we have two radii. You have this radii here, radius. You have another radius here. Sorry about that. Let's just yeah. So I'm saying we have a radius here. That's a radius, and here's another radius. Okay, and then we have an arc. So the radius, the radii, two of them, and the arc together. This region is known as a sector. Okay, but what about when another important thing I should have mentioned? What about when you let's look at this, for example. Suppose we cut a line like this. Okay, there's this region here, which is a part of the circle down here. This one is called the segment. It's called segment. So this is a segment. Okay, yeah, segment. But this one here is called the sector. So a sector is just a region which is surrounded by two radii and an arc. Parts of a circle. Now let's move on to look at angle properties in a circle. The behavior of angles inside the circle. So we have just seen a demonstration that the angle in a semicircle is always a right angle. Somewhere we have shown that. But how can we establish that indeed an angle inside a circle is a right angle? Remember that a right angle is a 90-degree angle. What this means is, suppose we draw a circle such as this one. Suppose we have a circle like this. All right, sorry about that. Suppose we have a circle we have a circle such as this one. All right, so we have a circle such as this. This is our circle. Okay, we can call this a circle ABC. ABC. All right, and inside it we have an angle, this one. So that angle is 90 degrees. So how can we show that indeed this angle is 90 degrees? So we can prove, we can have a formal proof to show that indeed the angle ACB, if you want to name it that way, ACB. So we have angle ACB, this angle here. How can we show that it's indeed 90 degrees? It's 90 degrees. Okay, all right, so we can set off a formal proof, to show that indeed that angle is 90 degrees. So in order to do that, just draw a line, from point C to O. So draw a line from point C to O. Remember that point O is the center of a circle. All right, so we're saying just join the lines CO. Just join here, and this line will be the radius. From our definition of radius, it's a line drawn from the center of a circle to any point on the circumference. So the line in the orange there is basically this one is basically the radius, okay, of this whole circle here. All right, that's very important to note. Okay, so if you refer to triangle AOC, we are referring to that triangle. Okay, if you refer to that triangle, OA, line OA is equal to OC. I hope we are able to see that. Both of them are radii. They are radii, meaning that they are originating from the center to the circle. So lines drawn from the center of a circle to the circumference are called radii. So these two lines are equal. So what are we saying? We are saying this line here is equal to this line. They are radii. They are radii. Okay, so radii are equal, especially radii of the same circle are equal to each other. Okay, in this triangle what? Triangle AOC. This side is equal to this one. The reason is they are both radii. Radii is plural for radius. And so because they are equal, OA is equal to OC. OA is equal to OC. Then the angle OAC is equal to angle OCA. Which angle are we looking at here? We are basically looking at these two angles. This angle is equal to that. Okay, so if you look at the triangle AOC, triangle OAOC, if these two sides are equal, what type of triangle is this? This is a triangle called isosceles triangle. It's an isosceles triangle. What is an isosceles triangle? Once again, all right, if you recall from your Form 2 mathematics, or better still Form 1, you learned that an isosceles triangle is one with two sides equal. So when two sides in a triangle are equal, the angles below those two sides are called base angles. So the angles that I have marked in blue here, this angle and this one here, are base angles of this triangle AOC. You need to get this right. I'm saying if you have a triangle like this, such that this side is equal to this one, then this angle here is equal to this angle here. So these two angles are called base angles. Base angles. So base angles in an isosceles triangle are equal. Alright, so this angle here is equal to this angle. So these two angles are the same. They are equal. Okay, so going forward in proving, if we let these angles be x, suppose this one is angle x, so if we let this angle x, this angle also x, then you can see that clearly, you see that if we let's go back a bit. Okay, so if we let these angles be x, so there's an x here, there's an x on this angle, another x that angle there. Okay, so we are saying if we let these angles be x, and we go on to look at triangle BOC. This time we are now looking at a different triangle. We are looking at this triangle here, this one. Earlier on we looked at this triangle here, this one, which I'm shading in red. Alright, okay, so we looked at this triangle and we said that with respect to this triangle, we said that the base angles x are the same, they are equal. Okay, now let's move on to the other triangle. In this case, this triangle here, this one, which I'm shading in purple, this triangle there, you can see clearly that in this triangle, BOC, side OB is equal to side OC. Okay, these two sides are the same. They are also radii. This is radius drawn from the center to the circumference. This is another radius also drawn from the center to the circumference. So that triangle, in this triangle, angle A and angle OBC, we are talking about this angle here is equal to angle OCB. Remember earlier on we said that this angle here is equal to that, and each angle is x. Now we can use the same for this other triangle, triangle BOC. We can name these angles also differently. Let's say y. So we name these two angles as y. So those two angles are equal. So look once again before we go that this angle is equal to this one here, and this angle here is equal to this angle there. This is great. Okay, this is really great. Okay, so if that's the case, then if you consider triangle ABC, if we add the angles up, add this angle x, this angle x, this angle y, and this one here, they'll add up to 180 degrees. The angles in a triangle. Remember in Form 1 you learned that the angles in a triangle add up to 180 degrees. Okay, All right, so if that's the case, then we can add all these angles and we equate the result to 180 degrees. So if you add, upon adding x plus y plus y, x plus x is 2x, this one here, and y plus y is 2y. So we equate this to 180 degrees. 180 degrees. Okay, now what do you know about these additions? If you look here, you see that we can push out the two, we can factorize. We have we have 2x plus 2y on the left hand side. So this 2 is common. You can take it out by factorization. So you have 2, then in brackets, open brackets, you have x plus y. That's what is being shown here. Okay, so equate these two 180 degrees. 180 degrees. All right, so if that's the case, now you can safely divide both sides by 2. If you divide both sides of this equation by 2, this will give you 90 degrees. Okay, so that x plus y will be equal to 90 degrees. But now, if you look at this, x plus y is that angle there. All right, it's that angle there. So what do you notice about that angle? This angle is an angle in a semicircle. In a semicircle. In a semicircle. So a semicircle, remember, is half of a circle. So if you consider this top part here, this is actually a semicircle. So this, we are saying the angle inside it, the angle formed at the circumference there in a semicircle is 90 degrees. Is 90 degrees. All right, I hope we're okay on that. Okay, so we are saying dividing both sides by 2 will give us 90 degrees. So x plus y is equal to 90 degrees. Therefore, we can conclude that this angle here is 90 degrees. So we have proved formally that an angle in a semicircle is equal to 90 degrees. All right, so let's apply this theory in solving problems, real-time problems. Okay, calculating the size of unknown angles in a circle, in a semicircle, to be specific. Okay, so calculate the size. Here we are asked to calculate the size of the labeled angles in the following diagram. So look at the diagram. It's a circle which you already defined, and this is the diameter. Then we have this radius. Here is another radius. Here is another radius, and then we have the angles labeled as 37. So we have 37 there. We have angle A, angle E, angle D, angle B, and angle C there. We are asked to find what these angles represent. Okay, so how can we find A? Angle A. Angle A is this one here. If we know this angle, then we can find angle A very easily, because angle A and the 37-degree angle are in a triangle which is isosceles. Remember that base angles of isosceles triangle are equal. So angle 37 degrees is equal to this angle here, the angle marked A. So right away we're saying A equals to 37. Their angles are at the base of an isosceles triangle. That's the reason, the justification why we are saying angle A is 37. As long as this is a radius, this is another radius, these two angles are equal. So if this is our unknown angle, but this one is known, that means we can deduce what A is. So A is equal to 37 degrees. I hope we are good on that. But if you look at angle B is where is angle B? Angle B is right here. Angle B is right here, this one. Sorry about that. Angle B is this one here, this one. But we know that angle A is 37. This one is 37 degrees. We just calculated up there. That is 37 degrees. But the whole angle here is 90 degrees. So how can we find B, angle B? Okay, so we are saying angle B is the whole angle, which is 90 degrees, minus A. But what is A? A is 37. A is 37. So subtract to find B. Simply subtract 37, which is we found up there, from 90 degrees. Where are we getting 90 degrees from? From here, because we just proved that that angle is 90 degrees. So the whole of that is 90 degrees. So if we know this angle here, we can calculate angle B by subtracting 37 from 90. From 90, it will give us 57 degrees. It will give us 57 degrees. Rather 53, sorry. 53. So this is 53. 90 minus 37 is 53 degrees. I hope so far so good. Right. My name once again is Mr. Pochilola. Don't hesitate to contact me in case you have any questions. I'll be more than happy, excited to talk to you. All right, now let's look at angle C. So angle C, if you look at the diagram once again, let me clear this part. If you look at this angle here and this angle here, they are also base angles of this triangle. The triangle remember that the sides of this triangle are equal. They are radii. Okay, so radii are equal in magnitude. That means the base angles of that triangle are equal. So if we know B, it means we also know C. These are angles at the base of a isosceles triangle. Which triangle are we talking about? We are talking about this triangle here. It has equal sides. It has equal sides. These ones is isosceles. Therefore, this angle here is equal to this angle there. Okay, so without much ado, in this case, it means angle C is also 53 degrees. And then we have angle D to calculate. Okay, so I want to draw your attention to this triangle down here. We just said that this is 53. So this angle here is 53. This one here, this one is also 53. Okay, yeah. But if you look at the entire triangle, let's say you're looking at this triangle here. Okay, this triangle here, the angles in it will add up to 180 degrees. Okay, so the angles in a triangle add up to 180. This angle here plus this angle here plus this one is 180 degrees. Okay, but we know that this angle here is 53. We know. Okay, we just worked out this one is also 53. But if the angles add up to 180 degrees, including this one here, what will be the value of D? So all you have to do is subtract. So D will be equal to 180 degrees minus the sum of 53 and 53 degrees. Okay, so instead of saying 53 minus 53, just take 53 times 2 and then subtract from 180. It will give you 74 degrees. So this angle here is 74 degrees. Add this, subtract from 180. We have one more angle to work out. So in this case, we're going to go to move on to look at how we can find the other angle, the remaining angle. So the remaining angle also can be found by applying one of the facts you learned in mathematics in Form 1, that adjacent angles add up to 180, or angles on a line add up to 180. So take this angle here, take this angle here, take this angle here, add them up, they'll give you 180 degrees. We call them adjacent angles on a straight line. Okay, so adjacent angles on a straight line up to 180. That means D plus E is 180 degrees. Okay, but we already know what D is. So D is 74 degrees. But D plus E is 180. So how do we get this one? You simply subtract 74 from 180 degrees. So the result is going to be 106 degrees. Okay. If you have no question, if you don't have any questions, my name once again is Mr. Pochilola. Welcome to the platform. It is here where your future lies. All you have to do is follow on the videos and also subscribe to the channel so that you get notifications and pop-ups when a video is posted. So reflect on what we've discussed, and if you have any questions, don't forget to ask us. Don't hesitate to ask by simply sending a message to one of the numbers. So far so good, I hope, and that you are enjoying the lessons. Please, if you're not sure, just rewind, go back and watch the video a number of times until you are sure. Now let's move on to another property of angles in the circle. Okay, all right, so we shall reserve this part for the next lesson. For now, I want to leave you. So when we meet again, we are going to look at the angle at the center. By angle at the center, we mean this angle here. This angle, there's an angle here. So this angle is 2 times this one. If this one is x, then this one is 2x. Okay, whatever value x takes, up at B there, the angle at the center will be twice that. Let's say x is 20, then at the center an angle 40 will be formed. If x is 50, that means the angle at the center will be 100. So we are going to look at this in our next lesson. For now, let me leave you now so that you can reflect. But so far we have said that an angle formed in a semicircle is 90 degrees, and we proved that. Okay, and we also looked at how we can apply the fact to solve for unknown angles. We just looked at that as well. So next time when we meet again in this topic, in this lesson, we are going to look at another theorem which will prove that an angle at the center is twice that which is at the circumference. Okay, my name once again is Mr. Pochilola. Don't forget to subscribe to the channel so that you get notifications on the videos that pop up. Thank you very much. Bye bye. Take care of yourself.